Hi everyone. Today I'm going to be going over the ideal gas law problems, just working through the solutions for you so that way you can follow along and check your work as necessary. So if you look at the top here, there's a couple instructions. First, we need to read the problems carefully and identify each of the variables. Then we're going to make any necessary conversions so that way our data units match the units for R. And then we're going to solve for the ideal gas law for the variable that we're trying to find. So there's a little hint box here. The only R that we're going to be using is the 0.0821. Hopefully you watched the video about the ideal gas law where he shows you the different R's that we can have. But as far as this class goes, you'll just need to know the one R for ideal gases. Remembering that we need to add 273 to all of our Celsius temperatures to find Kelvin. 1 liter equals 1,000 milliliters. And then these are all of our unit conversions for pressure. But for now, we're just going to have all of our pressures in atmospheres, so you won't need to worry about those. But just know that there are different units of pressures out there. So I'm going to start here with number 1. Number 1 says, what is the volume of 0.283 moles of helium collected at 200 degrees Celsius and a pressure of 0.75 atmospheres. So what I'm going to do first is I'm just going to identify each of my variables, my P, my V, my T, my N, my R, and we're going to see what we're looking for and what we have. So I'm going to start first by writing out my list of all my variables that I need. So I need to know what P is, V, N, R, and T. So my pressure I can find in my problem, it is 0.75 atmospheres. My volume is what I'm being asked to find. What is the volume? So I'm just going to put a question mark there. That's what I need to know. It says, what is the volume of 0.283 moles? So that is in my number of moles. I'm just going to write 0.283 moles right here. Remember, MOL is short for MOLES. My R is 0.0821. And then I'm going to write my T. My T's temperature is 200 degrees Celsius, but I need to add 273 in order to find the temperature in Kelvin. So my temperature is 473 Kelvin. So next I'm going to write out my equation, my ideal gas law equation. That is PV equals NRT. And then I'm going to just start by plugging all of my variables in. So my P is 0.75. My V I don't know, so I'm going to leave that as a variable. My N is 0.283. My R is 0.0821. And my T is 473 Kelvin. So now I can just solve for the unknown variable B that I have. So I'm going to start by multiplying all three of these, which is going to give me 10.9898. So I'm just going to go ahead and round that off to 10.99 equals 0.75 V. So I want to get V by itself, so I'm going to divide both sides by 0.75. So those 0.75s cancel out, leaving me with just V equals 10.99 divided by 0.75. So when I do this calculation, I get that V equals 14.653. So I'm going to go ahead and just round that off to 14.7. And then I need to go back and look at my R to know what my units are going to be. This was liters times atmospheres per mole Kelvin. So we plugged in the Kelvin, the moles, and the atmospheres, leaving our units to be in liters. So our volume is going to be 14.7 liters. Moving on to number 2. Number 2 says, what would be the pressure in atmospheres exerted by 0.0692 moles of a gas with a volume of 14.23 liters and a temperature of 20 degrees Celsius? So I am going to start by listing out all of my variables. So I'm going to start off with P, V equals N, R, and T. So I'm asked what would be the pressure in atmospheres. So I'm going to put a question mark for that. My volume is 14.23 liters. My number of moles is 0.0692 moles. My R is the same one that we're going to use all day. 0.0821 liters times atmospheres per mole Kelvin. And then my temperature is 20 degrees Celsius, which I need to add 273 in order to get into Kelvin. So it's going to be 293 Kelvin. So then I'm going to move on to my ideal gas law, PV equals nRT. I'm going to plug in everything that I know, leaving the things I don't know. So pressure, I don't know, but I do know my volume. It is 14.23 equals 0.0692 moles times 0.0821 times 293. So I'm going to solve this side. I'm going to go ahead and multiply those together, and I'm going to get an answer of 1.6646, which I'm going to go ahead and round off to 1.66. So I've got pressure times 14.23 equals 1.66. So divide both sides by 14.23. And I can solve for my pressure. So my final pressure is going to equal 0.1166. So I'm going to go ahead and just round that off to 0.12. And because our gas constant is in terms of atmospheres, that means my pressure is going to be in atmospheres. So my pressure is 0.12 atmospheres. Moving on to question 3. So number 3 tells us how many moles of argon would occupy 17,000 milliliters of gas at 1.19 atmospheres and 24 degrees Celsius. We do have a hint here. We need to convert our milliliters to liters. But I'm going to go ahead and write out all of our variables first. So I've got pressure, volume, N, number of moles, R, and T. So I'm told my pressure is 1.19 atmospheres. I'm told my volume is 17,000 milliliters, which we want to convert to liters. So if you remember from the top, there is 1,000 milliliters in every 1 liter. So then this means I have 17 liters. N, my number of moles, is what I was asked to find. So I'm going to write a question mark there. And then R is the constant. We always use 0.0821 liters times atmospheres per mole Kelvin. And then my temperature was told to me as 24 degrees Celsius. I need to convert that into Kelvin. So I'm going to take 24 plus 273 for a final temperature of 297 Kelvin. So I've got all of my units written out here. So now I'm going to go ahead and just write out my ideal gas law, PV equals nRT. I've got my pressure, 1.19, times my volume of 17 equals N, the number of moles, which I don't know, 0.0821, and then times 297. So I'm going to divide these two to this side. So I'm going to get 1.19 times 17 divided by 0.0821 times 297 equals N, the number of moles. And then when I solve all of those numbers, my number of moles is going to equal 0.0821 It's 0.82965, but I'm going to go ahead and round that off to 0.83 moles. So that is my final answer in terms of moles. Moving on to question 4. So number 4 says how many moles of chlorine would exert a pressure of 0.81 atmospheres in a 3.83 liter container at standard temperature. So standard temperature and pressure is 0 degrees Celsius, otherwise known as 273 Kelvin. And it just says at standard temperature, but just for your information, standard pressure is 1 atmosphere, but you can see we are not at standard pressure right now. So we're going to plug in our pressure, our volume. N is the number of moles we're looking for. We've got our R and we've got our standard temperature. So I'm going to go ahead and plug that into my PV equals nRT equation. So if I do that, I get 0.81 times 3.83 equals N times R times T. So I can divide these to the side, just like I did in number 3, and I'm going to get an N that's equal to 0.1384, which I'm going to go ahead and round off to 0.14. So I have 0.14 moles in this container at a pressure of 0.81. The container is 3.83 liters at a temperature of 273 Kelvin. Moving on to number 5. So number 5 says what pressure in atmospheres would be exerted by 0.0229 grams of oxygen if it occupies 31.2 milliliters at 100 degrees Celsius. It does give us a hint to convert grams to moles. And as you can see, I have the setup here. I've got the pressure, which is what it's asking us to find. I've got the volume, which they gave us in milliliters. So we need to divide by 1,000 in order to get into liters. So we have 0.0312 liters. I've got in the number of moles, which they didn't give us, but if you look at our hint, we can convert grams to moles, which I'll do here in a minute. I've got my R, which is 0.082, and I forgot the 1 there, 0.0821. And then I've got my temperature, which is 100 degrees Celsius, plus our 273 to get 373 Kelvin. So going back to my number of moles, I can find that using my grams. If you remember back to mole conversions, which we've done pretty much this entire year, I can take the number of grams I have and I can use the molar mass from the periodic table of oxygen. So 1 oxygen weighs 16. So if I have 2 oxygens, it would weigh 32 grams. So I put that 32 grams on the bottom with the 1 mole on top, multiply across the top, divide by the bottom, and that gives me a total number of moles of 0.0007156, so I'm just going to say 72 moles. So I can go back up here and I can plug that in here. So 0.00072 moles is how many moles I have. So I can go ahead and start plugging into my problem. I've got P, which I'm searching for, times 0.0312 liters, times 0.00072 moles, times 0.0821 is my ideal gas law constant, and my temperature of 373 Kelvin. So I can multiply all these together and divide by this guy. So I'm going to get a final pressure equal to 0.70669, which I'm going to go ahead and round off to 0.71 atmospheres, because if you remember, our R is liters times atmospheres per mole Kelvin. So my pressure is in atmospheres, so I have 0.71 atmospheres. Hopefully this helped you out. You should be ready, if you got all of these correct, you should be ready to move on to the prove it.